Welcome back, students. We are here for our bonus module on the Python Intro to Python Programming course. I wanted to let you guys know the reason why we included this module in this course is because it offers a little bit more of an in-depth understanding of Python. So you want to make sure you go through all the lessons before you get into objects or object-oriented programming within Python. It's still a concept that struggles many Python developers, even in their journey of learning Python. It's a construct and it's a specific type of way you're going to write your code. The type of code we've been writing before is considered procedural programming. So now we're going to be learning object-oriented programming in this exercise. In this specific video, we're going to be going over all the principles of object-oriented programming within Python and going over how to write code in this paradigm and utilizing some of the skills we've learned in past lectures and moving on forward in our Python journey. So welcome back and let's get into it. So I'm wearing a different suit today because technically this is not Intro to Python anymore. Technically this is taking it a step up, but I hope you guys can enjoy this and take it for what it is. So let's get into it. As always, I am Matthew Wynn, teaching with the Florida Atlantic University Executive Education Program. So make sure to stay tuned and follow along. Let's jump into the PowerPoint. Alrighty, guys. So object-oriented programming, a Python bootcamp bonus video. Let's do it. Alrighty, so today we're going to be going over Python's object-oriented programming, aka POOP. We're going to be going over why it's important and why this programming paradigm will help you gain more knowledge and insight onto software engineering and how this all works together in the grand scheme of things. We're going to be talking about some useful applications of object-oriented programming. And as always, I included a meme here, me showing my friend 10,000 lines of, or 1,000 lines of C++ that can be written within 10 lines of Python. Alrighty, guys. So let's go into it. As always, I'm going to be hands-on. I'm using a Windows for today. Going to be working out a Jupyter notebook. If you have any questions, reach out to me at MatthewNGUYE2023@fau.edu. No name. No N at the end of my name. I know it's a spell error, but it's not a mistake, I promise. Alrighty, guys. So Python object-oriented programming. So to get into the overview of what object-oriented programming is, it's a programming paradigm that uses objects and classes in its design. So it's a way for you to structure your code so that you can use it, so that it's scalable, so you can use it in bigger organizations. You can work with other individuals to utilize this paradigm, and it's not as redundant as procedural programming, which we've learned before. Don't worry, there's a lot of similarities, and it's just something you have to wrap your head around for the first time. It took me a while to learn it, probably take you half the time it took me. In this case, this was developed in the 1960s, and it was utilized in complex systems, and you'll see why. It allows us to write code more efficiently and shorten our code and utilize and reutilize specific methods that we write within our objects and whatnot. Now that you're able to write Python and you can understand Python, this will be a breeze, and we'll move on to the next slide. Alrighty, guys, so these are the benefits. Modularity, which essentially just means that you're able to create a structure that allows you to break things down in complex systems. It allows you to manage specific classes and objects. It allows you to be able to reuse your code and maintain your code more easily. As you can imagine, if you're writing procedural programming notebooks in Jupyter Notebook, it can get kind of long. Which function is impacting which specific variable you're referring to, and inputs and outputs. So modularity is a benefit of using object-oriented programming. The next one is reusability. You're able to reuse your code on a wider scale. It's easier for you to reuse specific functions, which are called methods within object-oriented programming. So it's very reusable. It's very friendly when it comes to reusing redundant and the same functionality for specific objects or classes. In this instance, when we talk about reusability, we're talking about methods, which are essentially functions within objects. Sounds confusing, but when we get to the code, I promise you it'll be a little bit easier to look over. With that comes the scalability. A lot of big applications use object-oriented programming or a language that solely is object-oriented programming based, something like Java. And also something called inheritance, which we're going to be going over the 4 principles of object-oriented programming. Inheritance is one of them. Inheritance essentially allows you to create a relationship between objects. So your child objects can inherit the traits of their parent object. If you have a vehicle, you can have a car, you can have a motorcycle, you can have a bicycle that fit under the parent class of a vehicle, and it allows you to utilize some of the methods built into the parent class in those children classes. Procedural programming has its benefits too. It's simpler, it's easier to write, it's not as hard to kind of wrap your head around the paradigm of object-oriented programming. It is a little bit more efficient. I think it requires a little bit less computing power when you're utilizing procedural programming. That's all dependent on how the code is written though. You can have direct control. So a lot of times with object-oriented programming, things are abstracted away. So you don't really know specifically what the parent class or object is really doing in its behavior. So direct control allows you to have access to the specific variables, specific functions. And in that sense, if it's a smaller project, it's easier for you to find out exactly what is going on with your code. But when you want to scale and you want to work, at a bigger organization or work with more developed developers, object-oriented programming is the way to go. And also, it's just historically more popular than object-oriented programming, especially for people in the beginner intermediate phase. It's easier to kind of know and to use. Alrighty, so Python object-oriented programming, aka POOP. I'll let you do with that as you see. In Python, all elements are treated as objects in a sense. So we've already gone over this. You just haven't had the opportunity to really understand what we're doing with it. So data have attributes, and those are associated with methods. And in Python, everything is essentially an object. We just have been treating them as something different, such as variables or functions and whatnot. So encapsulation, we're able to understand how the bundling of this data and methods in what we learned functions are able to be concise in a structured manner that allows us to utilize these behaviors and this data in a way that's easier for us to understand once we get a hang of how to write Python code in relation to object-oriented programming. Inherent object-oriented programming principles, it's easy to implement the principles once you understand the design of the code, which we'll be going over. And it allows for you to have a more versatile application. It allows you to have more transparency in the code that you're writing, and it allows you to utilize the ability to scale an application without having problems breaking in code layers and functions and whatever. So that's the overview of this. Very, high level understanding of Python object-oriented programming, but let's get into the code so you guys can understand how we can apply this to our skills. So we have something called a class. A class is like a blueprint to what we're going to be doing inside of OOP, or object-oriented programming. So think of a dog, right? A dog is a general concept, and that dog has attributes of it, like its color, its paws, its age, its name, right? And then a dog has methods that it can perform. For example, a dog can run, a dog can bark, a dog can eat, a dog can play. There's a lot of different things that a dog can do. So inside of object-oriented programming, we create a class, and that class is going to reference the attributes of the specific thing that we're trying to create, such as if we want to create a dog, we create the attributes like breed, color, weight, age, the ones I said before, and we'll create methods so that these dogs, or this dog class can do. So what we want to do, it's not very helpful just to have a dog class. It doesn't seem very helpful, it's very generic. But what we can do is we can create instances of our class, and we can have our class have an instance. So we can have an instance, and that's considered an object. So we have the dog class, right? DOG, and we have a dog named Buddy. So we can create an object. Basically, it's considered an instance of the class. So just think of it as a subset of that class that's called Buddy. So we can attribute these values, such as its breed, its color, its weight, to this specific object called Buddy. So we're able to do this, and we can call this object buddy and call its actions in order to allow us to manipulate whatever code we're writing. Complicated, but very simple. So this is how it's written out. Class dog, in this case, we're going to create a class named dog. And in this case, the dog is going to do nothing. So we're just going to pass. Now we'll set a variable equal to dog. And we'll say the variable is equal to dog object because that's an instance of the class, aka an object. And we'll print the dog object. And as you guys can see, Python spits out an object with its ID. So in this case, we're able to see how we created the object inside of Python, and we're able to see what Python thinks dog object is. It's an object of the dog class. So it's saying the main .dog, which is the class, and it's an object at the ID. It attributes an ID for every instance of a class that you make with this. So that's the basics of how you write a class within Python, but again, not super helpful. So let's look at methods, which are functions that we define on a class, and they provide a behavior. Like I said, there are multiple ways that we can think of methods in terms of an object. We can think of a car or a vehicle object, and we can say that the vehicle has its attributes, which is like the name of the vehicle, the color, the brand, any of those things, the year it was made. And then we have methods. So methods are things that we can access so that we're able to provide actions on that specific object. In this case, we have the vehicle object, we have the vehicle class, and the methods might be drive, stop, fill up gas, whatever those methods might be, that's up to us. So we want to start, when we create a class, with the init constructor. So basically the init constructor, it seems kind of like, oh, wow, that's a little bit difficult to understand. So we start with something called the init constructor. So basically the init constructor is a method in Python that's known as an constructor that invokes the object when created from a class. The purpose of this constructor is to initialize those attributes like the vehicle make, the vehicle model, the year it was created, if we're using vehicle for an example. And it allows us to create these attributes that we create inside of our class. Now, inside of this init constructor, we're going to start it with the def keyword like a function. Now, we're going to pass it the first parameter as self. Now, the self parameter is actually referencing the actual object itself or the actual class itself. And it allows us to access those attributes and the other methods on that specific class/object. Now, we're able to encapsulate and structure our object-oriented programming notebook in Python to organize our code. And it doesn't make much sense now, but let's take a deeper look at the init constructor itself. So when you create a new object, let's say from the vehicle class, the init method is automatically called with all the arguments you're going to pass to that class. So you want to keep that as the first, you can think of it as a function, but it's really a method that we're calling within that object. We're initializing the attributes in the object. So we're basically giving those attributes first. The self keyword is going to be a parameter like we pass into a function. It's always going to be used the first parameter, and it'll be ignored when you call that object later, or you call that class later by creating an instance. So you'll always have the self keyword in there. And it represents the instance of the object itself. So it's just referencing the object itself. This is what it'll look like. So in this case, we have a class dog, right? We have the class dog. So in this case, we're initializing that self.name is equal to the name of the dog. So it's equal to that second argument. Self.breed, it's referencing the self parameter, the first one. And we do .breed, which references the breed that we pass it, and self.age, which gives us the age of the dog in this case, so we'll have that equal to age. Now we're going to have a method called def bark, just like a function, and we're going to pass it the parameter self. In this case, this method is going to print the dog's name, and it's going to says woof, right? Or woof. So we'll set dog1 equal to dog, which is setting it equal to that class. This is an instance or an object. So an instance of the dog class or an object. And we're going to pass it the name of the dog, the German Shepherd as its breed, and the age of 5. So when we do dog1.bark, we're going to be calling that method from that object dog1, which is going to take it from the parent class of dog, and it's going to print Coco says woof. Now, if we do something called vars, which is just a function built in Python, and we do vars dog1, it's going to print out a dictionary of the specific attributes of our instance of that class dog. Confusing, I know, but in this case, just think of it on a high level and think of the class as being the top, top dog, no pun intended, and anything under it, or, children, classes, or even instances of the object will take in all of the things that we've written inside of that class, and you'll be able to use it. Alrighty, guys, so that's the basics of object-oriented programming. Now let's get into a little bit more of what we can learn from object-oriented programming. Alrighty, so let's get into those principles. The first one is going to be inheritance. So inheritance, think of it as children and parents. So in this case, we have new classes that we can create that will inherit the properties of that parent class. So if you have a vehicle, we used this example before, with properties like speed and weight, or attributes like speed and weight, you can create a new class called car, and these properties will be inherited by the car, because we know a vehicle could be a truck, could be a bus, could be a car, and we know that a car will have the same properties / attributes as the vehicle. Same thing as methods. We know that a car will drive just like a vehicle will drive, just like a bus will drive. So we can see the vehicle as being the parent. We can inherit these specific functionalities or methods and attributes inside of the children class. So it basically promotes your code to be reusable, and it allows it to be scalable as well. It allows you to have a structure, so you can structure your code as follows. You want to create a parent class in pretty much every single program you'll write, and then have the children class. So that's inheritance. And just to let you guys know, when we write the code, it'll be a little bit more apparent, but this is just a high overview of all these principles. Next is going to be encapsulation. So encapsulation allows us to have some sort of data maintenance and data governance over the stuff that we're feeding that specific block of code. So it allows us to bundle our data in attributes and methods that will operate in a single class or unit, and it will restrict some of these attributes or methods if we tell it to be restricted. So in this case, we can have a bank account class that might have a private attribute for the balance. Let's say we don't want people to manipulate the balance unless they call a method like debt deposit or withdrawal, which will influence the balance. It basically protects data integrity and allows us to control how our code is being manipulated if we were working with others, or if we have an interface that people are putting inputs into, and all that kind of stuff. The next one is going to be polymorphism. So this one is a little bit tricky on the mouth. Weird word. It sounds very confusing, but it's actually not as bad as you think it is. So inside of polymorphism, we allow objects or classes to be treated as objects or classes of a superclass. They don't have to be parent and children, but what we can do is we can actually write a function, or we can write a method for draw. So we have a circle and a rectangle in this case, and we both want to have the same implementation. We want to have different implementations, but we want to have the method do the same thing. So what we can do is we can actually call a function outside of each class and pass it the class of the either circle or rectangle, and we can call that draw method, because we know that drawing a circle will be different from drawing a rectangle. Can be similar with something like languages. We can have different language classes, and we can have a function that calls on the method for, let's say, saying hello or saying goodbye, and we can call the function and feed it a parameter of the instance of the class and have it run differently. So if we have two languages like English and Spanish, we know that in English and Spanish people say hello typically, and we can have that be a method on our class, but we can also write a function called hello, and we can pass it the language class, so English or Spanish, and we can actually have those two print out two different hellos. So one will be hello and the other one will be hola. That's polymorphism. The last one is abstraction. So in abstraction, we can actually force people to use specific methods in our code that allows us to have a focus on the essential features of our code, and it allows us to have better security over how our objects slash classes are being manipulated and being used in our code. And it allows us to require specific methods from our class to any other children that are going to be utilizing some of those methods of the parent class. In a simple case, let's say we have shapes. If we have shapes, we can pass it abstract methods by bringing in a library called abstract base class. So don't worry about that. We'll go over the code. But basically, we can require that our children classes or the other classes to actually make it a requirement to have these specific methods attributed inside of those classes. Again, when looking at code, it'll be a lot easier to think about and visualize. But yeah, so that's pretty much it for today. We went over object-oriented programming. We apply these concepts to problems, which we'll do in the notebook. And always keep on learning, guys. So let's hop into the notebook as always, and let's get into the real deal stuff. Alrighty, guys, we are in our Jupyter notebook now. Before we get started, I wanted to run these couple commands, these couple installs for you guys to try. I did not want to include this on the intro course because I wanted you guys to get the syntax and everything inside of Python and not have the ability to read and write based on something giving you an input. But these are very useful, and most code editors outside of Jupyter Notebook offer this. Basically, you're going to want to run these 3 lines of code, and if you go back out to the Jupyter Notebook, you'll have a NB extensions, and you'll want to click on the Hinterland plugin right here. So click on Hinterland, and that's going to allow us to actually, so if we go back to our Jupyter Notebook, it'll allow us to actually write variables and write functions, and we can actually have an autocomplete function that will give us what we're writing about. If you're using Pandas, for example, you can get some of the in some of the library's functionality. So I already have it installed, but in this case, let's say I want to create a variable called hello. Hello is equal to hello. Now, if I want to reference this variable, before we'd have to write the whole thing out. But if I want to do print, in this case, if I do this, I can start typing and boom, pops hello. So that's pretty cool. Wanted to show you guys that. And also there's some different methods and stuff. It'll be useful when we have methods on our objects because then we could just type those methods in and it'll autocomplete. But yeah, that's that. All right, so let's get into object-oriented programming again in the code now. So again, we have this dog class. We're going to just have it pass. We're creating a variable called dog object that's going to be an instance of this class. So this will be our object, and we're going to print the dog object. Let's just run this. Again, it gives us the main object, the parent class, and then it says it's an object at this ID. Simple enough. A little bit more complicated. Let's get into the dog class again. In this case, we're going to have the class of dog, and we're going to say def init. We're initializing this class. We're passing it the self parameter as the first one, as always. And then we're passing a name, breed, and age. We're saying self.name is equal to name, self.breed is equal to breed, self.age is equal to age. So in this case, we have a method called bark, and then we looked over this already, but we're passing it the self parameter, which is just saying this is the attributes that we're going to be passing this method. And we're saying print self.name says woof. So let's go down here and let's write a little code. So what we're going to do is we're going to set Coco equal to dog, right? So we're initializing that instance of the class. And what we're going to do here is we're going to do Coco dot bark, right? And what we're going to do here is we're going to feed it some of the parameters. So we're going to say the name is Coco. We're going to say the breed is a Doberman. And we'll say the age is 5, right? So let's say coco.bark. Let's run this. Oops. Coco.bark. Forgot to finish that one out. Let's run this. Click run. It says Coco says woof. So we're getting that method from this class. So if I decide I want to write another method, so let's say def running, and we'll pass it self. And from here, we'll say print f string self dot name is running. So if we call this method, so instead of bark, we say running, Coco running. We can play or press run, and we're saying Coco is running. And now if we want to change this, Coco is running at self.age years old. Now let's just run this again. We're saying Coco is running at 5 years old. Awesome. Cool stuff, right? Really, really useful, and you'll see exactly why. So let's go through inheritance. So inheritance, guys. So we have a parent class in this case. So we have a parent class of vehicle. We're initializing the attributes here. So we're saying init self, speed, and weight. So we're saying the speed equals speed and the weight is equal to weight. And in this case, we're going to write a method that's going to say display info. So we're going to be saying, we're going to pass it to self again, and we're going to be saying speed, self.speed, and the weight is self.weight of that vehicle. And in this case, we're going to be talking about inheritance. So we'll have a child class, and that child class is going to inherit whatever we pass it. So it's going to inherit the vehicle class in this case. So in this case, we have the self, the speed, the weight, and the brand. We're adding a brand here to those attributes, right? So we have a new attribute that we're adding to this child class that's not within the parent class. So next you can use something called the super function or method within Python. We'll call it a function. It's built into Python, and basically what it's saying is we're going to be taking these two parameters, which are attributes in this class, and we're going to be applying it to the car class, the child class in this case. And then we're going to initialize a self.brand because we don't have a brand on the vehicle. It's only irrelevant to this car class. In this case, we're going to be doing the same thing. We're going to be displaying the brand in this case instead of displaying the information. But we can still call this method on the car class because the car has now inherited the methods of the vehicle class, which is the parent class. So in this case, we have my car is equal to car, and we're feeding it the parameters. So it goes 120 miles an hour. It weighs 1,500 pounds, and the brand is Toyota. Right? Those are the three parameters we fed the child class, which is a car. In this case, we can do mycar.displayInfo, which is the inherited method of that parent class. So we're inheriting this display info method. So we don't have to write it again, right? We don't have to copy and paste it and put it into this class. We already inherited from the parent class. And then we can also call this other method called display brand, which is only local to that child class. So simple enough, something that you can use as a principle when writing code in object-oriented programming style, and that's that. So let's move on to encapsulation. So encapsulation is important because it provides us with a way to have some sort of data governance, some data security on our actual information. So this is going to be encapsulation. We're going to have private attributes on specific things when we're writing code, right? We don't want someone just to be able to access someone's balance in this case. So we're defining the class as bank account. And in this case, we're initializing the first attribute, which is the balance. We're going to set that default equal to 0. So if we try to access the account balance, so in this case, down here in the code, I have the account balance equal to 1,000 in this case. So if I try to do something like this, print account dot underscore balance, right? I try to run this. I'm going to get an attribute error. It's saying that the bank account object has no attribute balance. We know it does. So what this does, and we do this by calling two underscores by the attribute that we want to be private. If you do one underscore, it's not going to throw you an error. It'll just tell you what you want to see out of it, but it's like good practice for keeping it private. But in this case, if you do 2 underscores, Python will know that it's a private attribute. And instead, what we want to do is we want to write a method that will get us the balance. If we want to actually know the balance in this case, we'll have that method run. So we'll have a return self.balance. That's how we'll access that specific attribute. Now, what we can do is, in this case, we're having a bank account class, right? And we want to be able to do some stuff to it. So in this case, we're going to have a deposit method, which is going to take in self again, which is just that it's referencing that class. And we're going to have an amount, and we're going to say self.balance, and we're going to add that amount. So plus equals, remember from the beginning of Python, it just adding whatever value, and now that now this attribute is now equal to plus equals the amount. And if we want to withdraw, we're gonna write this method. We're gonna feed it again the amount that we feed it once we call this method. So we'll call that method with an amount. We'll call the withdraw method, and we'll say here if the amount is greater than the balance, so self.balance, then we'll print insufficient funds, and then we'll stop that specific method. Now, if we want to subtract that, let's say our balance is actually less than, or our amount is less than our balance. What we'll do in this case is we will minus equals, so the same thing as plus equals. Now the self.balance is going to be subtracting that amount out, and now it'll be equal to that amount. So let's run this. Let's run the get balance first so you guys can see what I'm talking about. So if I run get balance, it'll get us that balance. If I don't pass this anything and I run this again, our balance is going to be 0. So if we run account.deposit and we also run the get balance, what do you think might happen? We'll have 100 because we're depositing $100. Now, if we run both the account.withdraw, account.deposit, and we get that balance, we're going to get 50 since we're depositing 100 and we're withdrawing 50. Now, let's say we want to comment this one out and see what we get here. It's going to return us insufficient funds because that's part of our if statement. You can't take out more money than you got in the bank. So that's encapsulation for you guys. Let's move on to polymorphism. So polymorphism is an interesting concept, right? We have 2 classes here. We have a class called circle, and we have a function called draw, or we have a method called draw. We're passing it the self in this case, and we're saying drawing a circle. In another case, we have the rectangle. We have a method called draw. We're passing it the self parameter, and we're going to be drawing a rectangle. Now, let's say we have a function outside of these classes called render shape, which is basically just going to load our shape. So instead of passing this function specific variables in this case, we can have 2 classes and instead just pass it the shape. So what we're doing is we're passing it the shape, and we're going to call on that draw method from the shape that we're passing it. In this case, we're going to be passing it circles or rectangles. We're going to pass it both of those classes, and it's going to expect an object with that draw method. So the only way that this works is if we have this draw method within these 2 classes, right? So we'll set our circle equal to the circle class. We'll set our rectangle equal to the rectangle class. And as you can see, if we run this, we have drawing a circle and drawing a rectangle. So you're able to actually run functions that will take a parameter of an object in, and it will run the specific function or the specific method that you have within that class. Very useful for being able to utilize multiple different methods based on a specific function. So in this case, we want to make sure that we're able to do things dynamically within Python. If we have 15 different shape classes, we'd be able to call each one of those shapes by running that function and passing it the instance of that shape. In this case, circle and rectangle. So pretty cool stuff there. All right, let's move into abstraction before we get on to this amazing problem that I have. And we'll get into that. And no short of me, I'm not amazing in any sense. I just came up with an exercise that I thought might be helpful for you guys to apply these rules. And that's really where this stuff is going to come into play, is when you apply these things to specific principles and practices within Python. So abstraction, what is abstraction? Abstraction means that we're going to be required to have specific methods for specific child classes. In this case, we're going to import ABC from ABC, or import ABC or from ABC, importing ABC. It's just a library in Python that we're going to bring this in from. So we'll write this line of code, boilerplate here, just kind of copy paste. We're going to have a shape called class. We're going to have a class called shape. We're going to feed it the ABC as a parameter, and we're going to say that the abstract method is the area, and the abstract method is the perimeter, right? So in this case, if we have a child class where we're passing it the shape class, we're going to want to make sure that these two are implemented in this child class. And we can do that by calling @abstract method, which will require these two methods to be in those children class. So in this case, again, we're having def, we're initting that specific part of the, that specific method, the attributes. So we're going to have self here, and we'll have side. So self.side is equal to the side that we pass it. And in here, we're going to have a method called area, which we're going to return the self.side times the self.side, which is just what a square does. To get the area of a square, you multiply one side by the other, which will be the same both ways. And then in this case, we're going to have the perimeter, which is we're going to pass it the self again, parameter, and we're going to return 4 times the sides, because 4 sides in a square, you add all the sides together, and that's it. So in this case, we'll set an instance of the class equal to square at 4. So we're saying that each side is equal to 4. So this is going to be our instance or our object of that parent class square, or of that class square. So in this case, if we print square.area and square.perimeter, which are two required methods inside of the child class of the square, we will get the perimeter and the area. So pretty easy enough. Abstract methods are going to require us to keep methods in children classes, or are going to require these methods to be called on. And this could be useful if you're doing something like calculating the volume or the area or the perimeter of a shape, or have specific methods that need to be called within each class. The other thing we did was polymorphism, so we're able to actually run specific classes based on a function. We're able to call that method within that function. We have encapsulation, which makes private attributes by the double underscore. And then we have inheritance, which has child and children classes, or child and parent classes, and allows us to inherit those specific methods or attributes from that parent class. Alrighty, guys, let's get into the problem now. So let's take a look at this problem. We want to look at the shipping company has a fleet of various vehicles, including cars, trucks, and motorbikes. Each vehicle type has a different shipping cost based on the size and distance that it needs to travel. The shipping company needs to accurately calculate the shipping cost for these vehicles and the overall profit of those given trips. Requirements: different vehicle types. The system should represent various vehicle types: vehicles, cars, trucks, and motorbikes. So we'll have the parent class of vehicles, and we'll have inherited children of cars, trucks, and motorbikes. The vehicle sizes, they're going to have their own sizes, and these are the sizes that we're going to attribute to those specific sizes. And we're going to be calculating our shipping costs based on the size and the distance traveled of each vehicle. So profit calculation. So in this case, the system must calculate the overall profit for the trip by subtracting the total shipping costs and the total revenue, giving a specific revenue per mile. So we'll feed those assumptions into our profit calculator. And scalability. So we want to make sure that we're able to add more vehicles, and we want to be able to change things like shipping costs in the future so that we're able to solve this problem in a real world scenario. I don't work for a shipping company, but I've written code to do things in this manner, calculate profit and loss based on specific classes within Python. So I'm going to pause. I'll give you the first little line of code, little answer right here. So import ABC from the ABC library and abstract method. So give it a try, and we'll hop back in and do it together. Stopping. All right, so I pulled up a Word document with the question here. So let's just get into writing the code, and let me walk you through the logic of doing this. So I'm going to copy this ABC from up here, just to paste this in here. That'll be the first thing we want to import those abstract method operators. So let's start. Okay, so we want a vehicle class. So let's say class is equal to, or class is vehicle, right? We have vehicle class. And we're going to feed it ABC. And we'll say this. And what we're going to want to do next is we're going to want to write a function. So we'll say def, oops. There we go. All right, and we'll say, let me move my computer out of the way. Okay, so we'll say def is equal to init. Beautiful. Init, self, and I think each vehicle is going to have a vehicle size. Okay, so size, right? I wrote this and I forgot the answer. Self dot size is going to be equal to whatever size we give it, right? Simple enough. All right, and we're going to have a shipping cost calculation for each vehicle based on size and distance traveled. So in this case, we're going to have an abstract method here because we're going to want every vehicle or every child class of the vehicle, so cars, trucks, and motorbikes, to have the shipping cost. So abstract method, and we'll say def shipping cost is self distance, right? We want to get the distance. And in this case, we're not going to have a distance on these specific vehicles. So we'll just pass that there because we're going to have it for the children classes. So let's create the car now. So we have the class of vehicles. So let's say class is going to be a child class of the vehicle, car. We're going to pass it the vehicle. And we'll say def underscore init. And we're going to initialize self. We're going to have size. And then for the vehicle, there's a cost per mile. So cost underscore per underscore mile, right? That looks good. All right. And for that, let's do a super, since we're not going to want to inherit, we're going to want to inherit the same things we had here. So super dot underscore init from the parent class. Size, it's the same thing as just doing size dot or self dot name or self dot size in this case, but let's just do this. And we'll say self dot underscore, underscore cost per mile is equal to cost per mile. In this case, this underscore is attributing the fact that we want it to be acting as a private attribute, but it's not an actual private attribute, just some naming conventions there. We'll calculate the shipping cost for this. So we'll say def shipping cost. Since it's an abstract method, we'll say self and distance, right? And we'll return, what does it say? Calculate the cost per mile specific to each type. The system must calculate shipping cost. Okay, so we'll return the distance times the self dot underscore cost per mile, right? Taking the distance and we're multiplying it by the cost per mile, right? And then in that case, we're going to have a rater here, or a attribute. That's not the right word. A multiplier of that size. So the size is going to be multiplier. So we'll do self dot size, right? Okay. Cool. All right, let's do the truck and motorbike. So for the truck, we're going to do the same. So let's copy this. Paste this, and we'll just change this to truck in this case. So it's going to be the cost per mile, shipping cost. It's going to be the same, and then we'll just change this to motor bike, right? We'll change that to motorbike. So everything should be the same if they're being calculated in the same way. Or let's calculate the shipping company. Let's make a class for that. So class shipping company. So what we want to do here is we want to, do the old dance of init. We want to init the self here, the object itself. And let's do self.fleet. We'll leave that as an open list. And what we're going to want to do is we're going to want to add each vehicle to the list. So we'll do add vehicle, self vehicle. Let me move this over so we can look at so we're saying profit calculation, subtracting the total cost from the total revenue. Okay. All right. So we'll do self.fleet.append. We'll append the vehicle. So we're going to add each vehicle to this fleet, and we'll say to calculate the profit, we'll do another method, calculate profit, and we'll say self, distance, revenue per mile, I think it's, revenue per mile. And let's close this out. And we'll say the total cost is equal to the sum. So we're going to do a for loop here. What we're going to want to do is we're going to want to get the shipping cost via the distance. So we'll say vehicle dot shipping costs. Shipping cost. We'll feed out the distance that we get here for each vehicle in self.fleet, right? So we'll do that. We'll get the sum of each vehicle, the cost, the shipping cost, and then we'll do the revenue, the revenue is going to be easy. We're going to be defining a distance times the revenue per mile that we feed it, right? So we're going to get that, and then we're going to return total revenue minus total cost. Cool. So we got that. Now let's go and let's actually test this out. So in this case, let's make a variable, or let's make an instance of the class. Let's say company is equal to our shipping company. Shipping company. Let's say company, we want to add each vehicle, add vehicle. Let's say car. And in this case, we get the 0.5 times the size per mile is going to be the cost. So we'll just say cars are going to be, let's say cars are equal to 3 for their size, and then the cost per mile, let's say 0.5. 0.5, or let's just do 0.5, make it cleaner. Close that out, and let's add all our other vehicles. So we'll do this, paste, oops. Paste. Let's change this to truck. I hate when my keyboard does this. Truck, and we'll say that is the size of 5. And let's say it's 1 in this case. So we'll close that out. And we'll say motorbike. And we'll say motorbike is 1. And let's say it's 0.25 per mile, right? All right, so what's next? So we need to return the profit in this case for our fleet of vehicles, right? So what we want to do is we want to say, we want to define the distance we traveled. So distance equal to 100. The revenue per mile, let's just say we charge 8. Let's say the profit is equal to our company instance, company.calculate profit. Company.calculate profit, and we're going to feed that distance and that revenue per mile, right? So next, let's do a print statement, and let's just say f string profit for a distance trip with a revenue per mile of $revenue per mile. is, or generates $ our profit. Okay, let's close this out, see if there's any bugs here. Let's run this. Oops, string literal at 56. What did I do? Oh, forgot to include this. Syntax errors, the most rudimentary errors. Forgot to make that equal to that. All right, let's run this. Okay, where is the issue that's lying in here? Oh, calculate profit. My keyboard's doing this weird thing. Calculate profit will just be the distance and the revenue per mile. All right, let's see if this works. Oops. Let's click run. All right, let's go. We got it. After a couple hiccups there, looks like it's working. So basically, I forgot to add a parentheses here, and I was having some keyboard issues where I was naming variables incorrectly. But for the most part, everything's looking pretty good. Let's run this again. Let's change this to 50. Cool, it works. Alrighty, guys. Well, I hope you guys enjoyed that video. That was a interesting exercise. I was able to get through some of the issues there. And, you know, that's all part of learning how to code. You got to go through some issues. So, alrighty, guys. I hope you guys enjoyed this lesson and this video. I hope to keep continuing to show you guys the beauty of Python and hopefully in another course later on in the year. I hope you guys have a great day and enjoyed everything in this course so far in this bonus lesson. If you've learned a lot, please feel free to reach out to me and let me know what you learned, and let me know if you have any questions about any of this. It can get kind of complicated, but I hope to have provided you a in-depth understanding of how to use object-oriented programming within Python. Hope you have a great day, and hopefully talk to you guys sooner or later. Feel free to always shoot me an email. I'm always around. Take care and have a great day.